to review a few important terms. Okay, so now that we've learned how to solve for sides, angles using sine, cosine law, we can start solving word problems. So here is some important definitions and formulas. Okay, angle of elevation and depression. Okay, so I'm going to use some colors here. I'm also going to have a ruler. If you have a ruler, this would be a good one. Okay, so don't judge me by my art skills, okay? Let's just put it this way. My pictures would never be displayed in the hallway, okay, if I would be an art. Okay. So the most important line when you're dealing with angle of elevation and depression is the horizontal line. You have to have a horizontal line present. So if this is if a person is standing here, this would be, I'll make this a dashed line. It's always there, whether you think of it or it's explicitly mentioned or not. This is a must. Okay? You cannot deal with angle of elevation or depression unless you have the horizontal. Okay? Then of course, if you look up, let's say there's a bird or a tree or a plane or a kite or something that's up, you're looking up, correct? So your line of sight between the horizontal and that object is going to be called the angle of elevation. So where do you start measuring? Just look up for a little bit here. Where do I start measuring? From the horizontal to the line of sight going up. That angle that is formed is called the angle of elevation. And so normally, your triangles will look like this. They will have the ground, and then they will have the line of sight, the diagonal, right, the slant, and then there'll be some sort of height. Whereas if you're looking down, let's say there's a bug on the ground. Okay, so now you're looking down. Okay, that angle, again, I'll ask you to look up here real quick. I start measuring from the horizontal, and then I go towards my line of sight. That is the angle of depression. So it is always with respect to the horizontal. Always. Students don't struggle with this concept like, oh yeah, there's the ground, that's my horizontal. I'm looking up, right? So this is a tree, let's say, and there's a bird on top of that tree. I can totally see how that triangle will form, right? The angle is right here. Okay, there's that angle that is given to me. That'll be a number, most likely, or they will ask you to solve it. If it's an angle of depression, it's a little trickier. So for example, let's say you're a pilot and you're flying a plane, you're up in the sky, right? And you're looking down at, let's say, a tree that is down here, or you're on top of a cliff. You're looking down. Where is your angle of depression? A lot of students, for some reason, want to put it here. That is incorrect. Remember, angle of depression or elevation needs to be measured from the horizontal, so it goes here. Okay, that is where the angle of depression will be located. And remember, both of these scenarios, the angle is measured from the horizontal, either up or down. Okay, so remember that. The next concept, which you are very familiar with, or at least you should be, is the concept of supplementary angles. But I will give it to you, I'll give you that in terms of trigonometry. Here's what I want you to imagine. Like, I'm going to give you a scenario. Let's say this is the ground, and at the end of this, there's a tree or a building or something standing at the end of that stretch. Okay? So let's say you're over here and you're looking at the top of this tree. Maybe there's a bird at the top, right? So you look at it, you're like, okay, that's my line of sight. This would be an angle of elevation here, correct? But let's just assume you're curious and you walk towards the tree and you get an angle of elevation. You're looking up again. Now you have that scenario. Okay? So let's say this angle, when you were further away from the tree, I need you to reason with me here. I'm just making up numbers, by the way. If this is 20 degrees, angle of elevation is 20 degrees, what would have to be true about this angle with respect to the one you started with? Would it be smaller or bigger? Bigger, right? The closer you get to something, the higher up you have to look, right? So this would have to be 30. Why am I saying this? Because sometimes the question gives you two angles of elevations and students mix them up. It's like, well, which one would it be? Which one would go here? Which one would go there? Well, common sense would dictate the further away you are, the smaller the angle of elevation. Do you see a straight angle there? You see a straight angle? Yeah? Question? I just made it up. Yeah, I just made it up. I think I just wanted to know that if this is 20, this should be 30 or something more than 20. Yeah, it's a good question. Do you see a straight angle? You see this one here? If that is 30, what do we know about this angle here? It should be 150, right? So supplementary angles. These two are supplementary. Or you can call them straight angles. So that is going to come in really handy down the road. How many triangles can you see? There's one here, there's one here, and there's the big one. So with one line, you've created 3 triangles, right? With this line, we've created 3 triangles, okay? If this is 20 and that's 150, what would this have to be here? This adds up to 170, right? That would be 10, yeah. Sum of triangles is equal to 180. Therefore, this would have to be 10. See how that works? One property led to another property, which all of a sudden you've got angles everywhere. And I want you to start doing that. You know a lot about angles. That's why I started with chapter 2. Now you can keep doing that. What is this here, guys? That'd be the height of the tree, correct? It makes a 90 with the ground. Now you can fill in even more, okay? You see how that works? So I don't have to give you a whole lot of information for you to start filling everything up with angles, okay? But I need to give you enough, obviously, to solve. Complementary angles, let's do that one. Let me think of an example here. Okay, so let's assume this is a cliff here. Write down cliff, because you might wonder, what is that? What did Mr. Dixon try to? A cliff or some sort of precipice? You're at top of a mountain that goes straight down. Who knows, right? But let's say this is the ground here. Let's say you're looking at something out here. Maybe it's, you see a deer walking way out in the pasture, right? You would have a line of sight going down. And please, I'm trying to get you mentally prepared for what we're about to embark in, okay? That's why I'm doing this. I'm not just wanting you to write down. I want you to think, okay? If I told you there's an angle of depression, you're on top of the cliff, they will talk about an angle of depression, you're looking down. Where would you put that angle? Let's say it's 20 degrees. You can't really show me, right? But what you should automatically say, oh, angle of depression, that means that I must introduce some sort of horizontal. It's invisible, right? We're just imagining a horizontal line. We're imagining that cliff, that surface up top continuing. This would have to be, let's say this is 30 degrees. Okay? What do you know immediately about this? If this is 30, then this is? It's not, this is 90 here. 60. Right? Because you've got a complementary angle there. We know that there's a 90 formed. If this is 30, then this is 60. So sometimes you will have to use complementary. Somebody said 150. That would be if you wanted to know this whole, like if you're dealing with this whole angle, this would be 150, but we wouldn't really want to, we don't care about this chunk, right? Because it's going into the cliff. So in this case, we would want to just worry about that corner, that 90, and so there's 60, there's 30. Question. Is this line, the dashed line, and this line, what would we call these two? Parallel? Yeah, okay. So what would the 30, what would this angle here and this angle here be called? Alternate interior, right? No way. No way. Don't get too excited, okay? If this is 30, then what is this? 30. Alternate interior angles, and we know that they're that this is 30. Hold on. This is a common mistake. Can you say that if this is 60, this is 60? No, because there's no parallel line here, right? If you had one here, then you could say 60, 60. You got to watch out. I'm using the 30 because it's touching this horizontal line, and this transversal is touching this other parallel line, so I can use the 30. But I could not use the 60, okay? Okay, let's keep going. Guy wires. Do you know what guy wires are? Guy wires are, you see hydropoles ever? A hydropole. You ever see these wires that support it? That is a guy wire. It's anything that's at a slant that is supporting a structure. It could be a post, it could be an antenna, it could be anything, okay? So guy wire is right there. Can you see that that's going to be a triangle if there's a guy wire involved? I hope so. There's the ground, there's the pole, you've got everything. Okay, you've got everything necessary. Well, why don't I'm just gonna let you know if there's a structure supported by guy wire, you have a 90 at that corner, unless they tell you that it's off, it's slanted. Let's say there could be a scenario where they say the antenna is slanted, it's not right, it's not straight up vertical. Then you can't assume that it's a 90, but other than that, you can always assume there's a 90 there. Okay, let's dive into scenarios. Ready? Okay. Okay, so here are some, I don't think you need to have this on your study sheet. This is what I generally do. This is me thinking out loud in writing, okay? In order for a problem to be solvable, you need at least 3 pieces of information. Just wait for now, okay, guys? Sketch your interpretation of the problem and label the unknown measurements. Like, what is it even asking me for? Is it asking me for the height? Is it asking me for the direct distance to that object? What is it asking me for? Yes. Yeah. Is it asking me for how far away horizontally I am from that object, right? What is it asking? Identify the unknown angles and or sides you'll be needing to calculate. And you can assign variables if you need. This is very important. Fill in all angles. Use sum of triangle. Use alternate interior angles are congruent. Subtract angles if you need to. Supplementary, complementary. Determine any other angles that you might be able to find. Okay? Watch this one. 4. If the height or the altitude is provided, you will be working with right triangles. Check if the information you transferred makes sense and is in the correct place. Set up and solve, include units, round to 2 decimals. Okay? All right, so here we go. I'm not going to solve anything here. I may come back to this later. Just make sure you pay attention because this is going to help you out solve the other problems. So let's say you have this scenario here. We're dealing with angles of depression. There's a ship, let's say, and the ship is looking at an angle of depression, looking backwards at an object here. And that same ship is at a different angle of depression, looking to the opposite direction. It notices something is here. This would be called what? This is the depth of the water, how deep the water is, but it is also known as the what of the triangle? Height of the triangle. You've got 2 right triangles. You've got this oblique triangle here. All of that gets mixed up. Sometimes one is more beneficial than the other. I will also tell you that if I wanted to know the distance from here to here, I could just solve for x, which is x is supposed to be from here to here. And I could solve for y and then just add them up. That would be one strategy of finding out how far these 2 objects are. Another strategy may be, if you know this whole angle here, you might be able to use sine law or cosine law to solve for the entire length all at once. We will see how that works. Let's fill in the rest. If this is 45, what can we say about this one? 45 also. If this is 30, then we can tell that this is 30. Can we find out more angles? Yes. If this is 30, what is this? Just this chunk right here. 60, right? Mr. Dirksen, how? Well, you could go 180 minus 90 minus 30, you get 60. Or you know that there's a 90 here. So if this is 30, that's 60. It's up to you how you want to do it. What is this angle here? This is 45. Then that's 45, correct? I'm going to use a blue pen for the next part. What would this whole angle be right here? I used easy numbers here, right? What's 60 and 45? 105, yes. Do you see how that works, guys? How many angles you can find just like that? Okay? Just like that, you find them all. Do you see a straight angle up here? Right? From end to end, it should be 180 as well. So if you go 180 minus these 2, you get the 105, right? You get that difference here. Okay. All right. Enough is enough. Let's go to the next one. Here, just pay close attention. I will try to be very specific on my problems because it makes it a whole different problem if you don't read it correctly. Here, you're in between the objects, right? You have 2 angles of depressions. You're in between somewhere. What about this one? You're at the pilot. There's 2 angles of depression, right? You see 2 angles of depression. You're staying at this spot. You're looking down here. You're looking down here. Maybe this is the beginning of the landing strip, and this is the end of the landing strip, and you're trying to figure out how long is that landing strip, right? Let's fill in angles. Let's do this. One transversal at a time. This 30 here, right? We know that this is parallel to this. We know that these are parallel. If this is 30, what is this one right here? 30, correct? If from here all the way to there, if that angle is 45, then I can come down this transversal and also call this 45. If I have that, if this is 45, what must this one be? Let's do some mental math here. 180 minus 45, 135. Can I find out more angles? What about this one here? Is this a triangle here? So I can go 180 minus this minus that. What is that, by the way? Is it 15? Oh, wait a minute. 15 and 30 adds up to 45. That checks out, doesn't it? 15 and 30, 45. So you could have gone 45 minus 30 to get that. You could use sum of 180 to get it. So there's different ways to get the same answer. Okay. If this is 90, this is 45, then I know that this is also 45, correct? So see how that works? What kind of a triangle is this if we've got two angles that are the same? Isosceles. What do we know about isosceles? Two angles are the same, then the two sides are also the same. More on that later. Right now, I don't want to bombard you with too many nuances, right? But anyways, these are, in my opinion, the two angle depression scenarios you can encounter. These are the more complex ones. I'm not going to lie to you. These are more complex because there's two angles of depression on both of these. Let's talk about angle of elevation on the back side. I'm not going to talk too much about this one, but if you've got, a hot air balloon, there's two people looking at it, right? And we're looking up from both, right? Like two people looking at it, looking up. You've got your two angles of elevation, right? Which one of these people is closer to the center line? How would you know? Yeah.
The 42 degrees closer, because the closer you are, the higher degree.
The higher the angle of elevation.
Yeah.
Yes, you're absolutely right. The closer you get to something, the more you're going to have to look up. So even though the diagram kind of gives it away anyways, remember, you're going to have to sketch your own diagram. I don't care if it's drawn to scale, as long as you draw it, like put the numbers in the right place, but I'm just letting you know that is something to take into account, okay? So there's a tower. Let's go. These ones are a bit more challenging. So this goes back to what I've talked about earlier. You start here, you move closer, and you move like 35 yards closer. Now your angle of elevation is this, but you can fill in the rest of the angles. This is 150. This is a straight angle. This is, help me out here, 5, right? Sum of triangle. What's this one here? 60? I'm just going off of this one here. 180 minus 90, that's 90, minus 30 is 60. So this is also sum of triangle. And so basically I've got all angles everywhere. Very solvable. Guys, the 35 that goes from here to here, correct? So look up here for a second. This is very important. So the 35 goes from here to here. So you got to follow those sides. So which angle is across the 35? It's this one, right? Not the 60. It's also not 65, because if you go 5 and 60, that's 65. That would be all of this. So don't be mixing up triangles. Okay? Let's keep going. What about this one? Can you think of a scenario where this would be the case? Is the person moving? The person is not moving, right? They're staying still. But what happens, like the person might be looking up. Maybe you see where a wire attaches to a tower, and now you're looking even higher up to look at the very tip of the tower. So, right, you go 20 and then you raise it even more to 50. How can we find out angles here? Why would this have to be right here? If it's 50 all the way and it's 20 here, then this is? Hey, there we go. Right? You can go 50 minus 20 if you want to show how you got that. It's 50 minus 20. You can find this one here. How? Sum of 180. If the 180 minus 90 minus 20, that would make this 70. What else can I find? You see this? See this straight line here? You're not excited, right? Like I should tap dance or something. This is 110. Whoa, right? And can I find the top here? Which triangle should I use? This big one? Sure. You can go 180 minus 90 minus 50. That would make this. Sorry, 90 minus 50, 40, right? 40. Yeah, 40. Sorry, I'm a little slow today. 40 and 110 is 150, plus the 30 is 180. So this triangle also adds up to 180. So I'm double checking everything is good. Yeah. Okay, I can give you all the angles in the world. Guys, listen to this one. I can give you all the angles in the world. Can you solve a triangle with only angles? You need at least one side. Minimum. Okay? In this particular scenario, listen carefully, what law would you use to start you off with this particular scenario? You only have one side, right? You have all the angles in the world, you have one side. You have you see the pair here? You would start with sine law. Can I tell you another secret? 80% of the cases are sine law. Because cosine law, what works with cosine law? Side, side, side. You need to have all three sides. You know, definitely this is cosine law. And then the other one is side, angle, side. So you would need two sides and the angle in between to do cosine law, right? So keep that in mind. All right. I think I've talked enough. Given everything I just told you, okay, I want you to sketch this scenario. Talk to your neighbor. Don't start solving yet. Just sketch it. Sketch it, and I'll do it with you. I'll come back in like 3 minutes to see